Hey AP Pre-Calc, this is Miss Adams from Flamingo Math. Let's look at parametrically defined curves for circles and lines today. This lesson will focus specifically on defining lines and circles parametrically. When you parametricize a curve, you translate a single equation in two variables, x and y, into an equivalent pair of equations in three variables, x, y, and t. You've seen the value of parametric equations giving more information, such as the direction of an object's motion over time. Let's consider the parametric equations in general form for x equals a cosine t and y equals a sine t on the interval from 0 to 2 pi. If we use a graphing utility to view the parametric equations for a being 1, 2, 3, 4 in the same square viewing window, can you verify that they are all circles and what is the radius? So you can take care of that on your own with your calculator, and you should see that yes, we have an A value that indicates the radius of each of those circles. So the A value tells us the radius of each circle. Next, let's consider the parametric equations x equals h plus a cosine t and y equals k plus a sine t on that same interval. If you graph the equations where a is 1 and use the following pairs of values for h and k, we're going to see that hk values move the center of the circle with the radius of 1. So the a value being 1 makes the hk causes us to move the center of the circle away from the origin that has a radius 1. So in the next example, if we take a look and use this 3, 4, we want to eliminate the parameter t in the parametric equations using any of the hk values and identify the graph. So I'm going to use hk is the ordered pair 3, 4. So that tells us x is 3 plus cosine t and y is 4 plus the sine t. Using our equation, x minus 3 squared plus y minus 4 squared is going to give us cosine squared plus sine squared. And we saw that in several lessons ago when we took that system of equations divided by 3. But here in this case, we're going to subtract 3 and subtract 4 and then square both sides. We know that this identity, cosine squared plus sine squared, is equal to 1, and that produces our Algebra 2 common formula for the equation of a circle, where the center is at 3, 4, and the radius is the square root of 1, which is 1. For example 2, can you write a parametrization for the circle whose center is located at -4, 5 and has a radius of 4? Then we want to sketch the curve at the right, show the orientation of the motion around the circle, and when t is 0, what is x and y? So let's get started on that. First, I graphed the graph for us here to take a look at it. You can see I've got it graphed here, sketching the circle at the right. I know the orientation because I just mentally plugged in 0 to our equation. But to write those two equations, we have x is the h value plus the a value times the cosine of t and y is the k value plus the a value times the sine of t. And then when t is 0, our xy point is 0, 5. So we started our graph right here at 0, 5. This was the start spot, and we went counterclockwise in that rotation. So our motion is counterclockwise. When we get to pi, if t is pi, we're at the point -8, 5. And our center was at -4, 5. Next, let's explore how we can get the particle to move in a circular pathway. Can you tell whether the object moves in a clockwise rotation or a counterclockwise rotation? Can the direction be reversed by a transformation of the equation? And then the next example will help us reach some of those conclusions. So in this first one, x is 2 plus cosine t, and y is 3 plus sine t. What do we know about that? We have a circle whose center is at 2, 3. So we got a sketch for that. We also know that the radius is 1 because our a value is 1. This is our h value and our k value. My graph, I'm sorry to say, is really tiny. So if we start here at 3, 3, because I started at 2 and went 1 unit to the right, the graph is going to go counterclockwise motion, counterclockwise, starting at 3, 3. In the next example, our center of the circle is at HK, which is 2, 3. The A value is 1, but we have a negative on the sign, so it's going to go clockwise rotation. And it would start 1 unit away from 2, so at 3, 3, and we got 2, 3, and 2, 4, and 1, 3, and 2, 2. So our circle is here. We're starting at the ordered pair 3, 3. This is our starting spot, but we're going clockwise because of the negative on the sign. So negative sign would go down, clockwise rotation. Part C, 2 minus cosine is going to make it go clockwise. Our h and k is still 2, 3. Needed bigger graph paper here, 2, 3, 2, 3. The negative on cosine is going to go clockwise, but we're going to start at 1, 3, and clockwise would go down to 2, 2, 3, 3, and 2, 4. So we're going to go this way, and starting here at 1, 3 is our start spot. We have to go clockwise, so clockwise is going to go up in this case. Clockwise from 1, 3, and then the last one, we've got 2 negatives on here. So we have an HK still at 2, 3. That's our center, 2, 3, and 1 unit away for each one. The circle is there, but because it's negative on cosine, I'm looking at this stuff, negative on cosine and negative on sine, we're going to start at 1, 3, so it's still on the same left side for cosine, but the negative on sine, where this would have been clockwise, this would make it go back to counterclockwise, and starting at 1, 3, counterclockwise is down. So counterclockwise, counterclockwise from the point 1, 3. Can you summarize what you just found? If you picked up on what I was saying, negative cosine moves our start point on the opposite side of the curve. And what does negative sine do? That reverses the order. And what did having two negatives do? Both negative. That kept the counterclockwise rotation, but it moved the starting point. So we retain the counterclockwise rotation, but it moved the starting point to the left side. Okay, so you may need that for future problems. Example 4 says, can you find parametric equations for the circle x squared plus y squared equals 9, where the parameter t is time in seconds, and the motion around the circle is clockwise. It begins at the point -3, 0, and requires 8 seconds to complete one revolution. So I'm a visual girl. My job is to start over here at -3, 0. We want that to happen at time 0. And we want to go, what did they say? Clockwise. So clockwise has to go this way. And it's got to take 8 seconds to get back around. That means this has to be 4. This has to be 2. And this would have to be 6 in order to end up at t equals 8. So using what we know about trigonometry, the period 2 pi over b has to take 8 seconds to complete one revolution. So b is our angle measurement of pi over 4. We also know that the hk value from this circle equation has to be 0, 0, and the radius has to be the square root of 9, which is 3. So the radius is our a value. Putting all that together, our equation for x of t would be, we need to go clockwise, so that has to be -3 cosine pi over 4t, and then y of t is sine of pi over 4t, and our domain or time interval would go from 0 to 2 pi. And that was pretty easy for day 1.